Okay, all right. So let's talk about this past paper question from circular measure. It says, in the diagram, ABC is a semicircle with diameter AC, okay, center O and radius 6 centimeters. The length of the arc AB is 15 centimeters. The point X lies on AC and BX is perpendicular to AX. Find the perimeter of the shaded region BXC. Okay. So whatever they have given as a statement was already there in the diagram. So we could not find any extra information from the statement. Now what we know is that AB is an arc, okay? BC is also an arc. Both of them are basically arcs, and you need to find out the perimeter of this shaded region. So this perimeter is going to include this length, then we have this thing, and then we have this curved arc BC as well. Okay, so let's talk about BC first. Let's see how exactly we are going to find out this arc length. Whenever you need to find out the arc length, that is not an issue. You only need to have this angle right here. Now, how do we find this angle? Only this angle. Can anyone tell me? How do we find this angle?
We can find the exterior angle first.
Yes, sorry, say it again.
We can find AOB.
Okay, very good.
Which is bounded by the 15 centimeters. Since
Excellent.
we have
Very good. Okay.
then
So,
we minus by pi.
yes, well done. That is right. Okay. What you can do is you can just find out this theta. And how do we find out this theta? We know that arc length is basically equal to r theta if theta is in radians. Okay, so we will assume that whatever theta we get after this is basically in radians. Okay, so arc length was basically 15. The radius is 6 centimeters because A is on the A is on the circumference of the circle and O is the center. So 6 is going to be the radius, and that's also mentioned specifically. So this would be 6 into theta, and theta is equal to 15 divided by 6. So you would get something in decimals, and that is 2.5 radians. 2.5 radians. And again, I'm telling you guys, this is going to be in radians. Why? Because we have used this formula specifically, and you can only use this formula whenever your theta used to be in radians. Okay, so this is in radians. So we got this as 2.5. Now, sum of angles on a straight line used to be 180 degrees or pi radians. So if I'm interested in finding out theta, I will do it this way. I know that 2.5 plus theta would give me pi radians. So theta would be equal to pi minus 2.5 and just 2 pi minus 2.5, and you are going to get 0.641 or 642, basically 0.642 radians. So this theta has turned out to be 0.642 radians. Okay. This is 0.642. Now when you have the angle and when you have the radius that was 6 centimeters, you can easily find the arc length BC. Okay, so let's do it here. This arc is basically going to be theta. Let me just write it down this way. Arc length is r theta whenever your theta is in radians. So the radius is 6 and theta turned out to be 0.642. You are going to multiply the two things, and this is going to give you 3.85 centimeters. So this is 3.85 centimeters. Okay. We have the arc length now. Next, we need to have BX and XC. Okay. Now I would want you guys to use your old knowledge and find out BX only. BX only. Okay.
Miss will use sine theta. Miss, you can also find BC using the, first you'll find AC, arc length, and then
Okay.
we will subtract it from 15, right?
1 second. Okay. So you're saying the entire arc length using 180 degrees or pi basically?
180 degrees.
Yeah, or basically the like circumference of a semicircle, right?
Yes, Miss.
Yes, very well done. Very good. Yes, that is also correct. Excellent. This would work because this time around, this ABC is basically a semicircle, right? But otherwise, if it was not a semicircle, then this method was mandatory. But you are certainly correct. If this is a semicircle, in that case, you can easily find AC using the fact that 2 pi r is the entire circumference. So it would be pi r. You can do pi r and then just take 15 out, and then you would be left with BC. Very well done. Very good point. Yes. Okay, yes. I'm just waiting. Just find out BX.
3.59.
Very good. Well done. Okay. So you have used sine here and it turned out to be 3.59. Similarly, if we talk about XC, what we can do is, just like you've used trigonometric ratios here, you can use cos to find out OX, and OX is going to be 4.807. So this length right here is basically going to be 4.807. This entire length was basically 6 centimeters. Just do 6 minus 4.807 and you would get XC. So 6 minus 4.807 is going to give you 1.193. So this length is 1.193. And in order to have the perimeter of the shaded region, you're just supposed to add the 3 values. So it would be 3.59 plus 3.85 plus 1.193. And this is going to give you 8.63 centimeters. This is going to be your answer. Okay. Now, this was a 6-mark question. And I can see that both of you are quite good at it. Okay. But some students find it a bit difficult. So what you guys need to do at that point, for a 6-mark question, you can certainly spend 6 to 8 minutes. That is fine. Even more than this, but 6 to 8 would be safe for you. Okay. And always use first 2 to 2.5 minutes for understanding the question, because if you won't understand the question, if you start doing it in the wrong direction, there's no point in doing the question, right? So spend good time in the beginning to see that what possible ways or what possible methods you have to solve this question, and then just use your time and everything to start working on it. All right, very good. Any difficulties with this question? Anything that you guys were not able to understand?
No, Miss, everything's clear.
Okay, perfect. Okay, now this was basically the homework question, but since I got your homework a bit late, so that is why I added it. Let's quickly just discuss the strategy, because this lecture is being recorded and some of the students are not here. So let's quickly talk about how exactly we would be doing this part, okay? This question. This was a homework question, right?
Yes, Miss.
Okay, all right, that's fine. Okay. So the question was, the diagram shows a sector AOB, okay, which is part of a circle with center O and radius 6 and with angle AOB equals to 0.8 radians. The point C on OB is such that AC is perpendicular to OB The arc CD is part of a circle with center O, right? Where D lies on OA. Find the area of the shaded region. Okay. Now for this question, basically what we have is, you guys can see two arcs basically. This is important. The diagram shows sector AOB. So AOB is a sector and this center is O, right? So for arc AB, O is the center. Then the arc CD is part of a circle with center O. Again, CD is another circle. CD is basically arc that is part of another circle, but again the what do you say? The angle or the center of that circle is O. So for both these arcs, the angle is 0.8 radians. The only difference is in their radius basically. For the bigger arc, the radius is 6 centimeters, and for the smaller arc, we do not have the radius. Okay, this is basically the idea in this question. Okay. All right, so for the first part, if we start breaking down this question, you need to find out the shaded region. Okay, so what we can do is we can find out the area of the triangle OAC somehow we can do that, and then you can just find out the area of the sector, that is ODC, and just subtract it, right? This is one possible method. And then I'm pretty sure you guys would be thinking about some other method which would be correct as well, but it could be that they're more time taking or stuff like that. Okay, that's fine. So we need to start our working and see how exactly we can find out the two areas. Okay.
Okay.
What we can see is that this 6 centimeters is basically OB, and the 0.8 is basically this angle. So this is also going to be your right angle triangle, and you can find out this angle as well. Okay, and this would help you find out three angles. Okay, another thing that's important, since OAB is basically a sector, if OB is 6 centimeters, this OA is also going to be 6 centimeters, right? So you can use 0.8 radians directly. You can find out the angle at A and then find OC. That's completely fine. Okay. So let's use 0.8 directly and let's use cos to find out OC. So we know that cos of 0.8 radians is basically equal to base over hypotenuse. Okay, now the base side is unknown. This is what we need to find, and hypotenuse side is basically 6 centimeters. So I'll multiply the two. 6 multiplied by cos 0.8 is going to give you the base, or basically OC, and that is going to be 4.18. So this is 4.18. Now everything is sorted. Now you have 0.48, that is not only the base of your triangle, but it is also the radius of the smaller sector, right? Using this radius and using 0.8, you can easily find the area of this ODC, and then you can use Pythagoras theorem and find this as well, because it's a right angle triangle, and then you would be able to find out the area of the entire triangle and then subtract the two. Any difficulty, anything that you guys were not able to do, your final answer should be 2.01. Just tell me if any one of you did not get this answer.
I got 2.0.
No mistake, Arc.
Okay. Sorry, say it again, Rafi.
Mr. Singh, I got 2 centimeters square.
Yes, that's perfect. That's perfect. Okay, so this means that you guys were able to do it. And this was the only difficult part in the beginning. Otherwise, the idea was clear. Very good. Okay, let's
What
talk. Yes, say now.
what I did was to find in the biggest sector,
Hmm.
right? And I find the area of the right angle triangle, then
Okay.
minus, yeah, and it gave me the DAC.
Okay, so you said you first you calculated the area of the bigger sector or of the smaller sector?
Yeah, the biggest sector.
Okay, but then when you will subtract the area of triangle, so you would get this basically. Are you getting this? Like the bigger sector is basically this entire thing, no? This entire thing is the bigger sector. When you will take out the right angle triangle, you would be left with this red part, but you were supposed to find out this shaded part. So I think first you did the calculation of the smaller sector. Like first, you need to calculate the area of the smaller sector. One second, look at this. This is what you need to find, right? The shaded part. That's obvious. Like this is what we need to calculate. So logically speaking, first you need to find out the area of the right angle triangle. Okay, once you have the area of the right angle triangle, you need to find out the area of the smaller sector, and then when you will subtract, you would get this shaded or this red region basically.
No, miss, I did. That's what I did. No, the first trial that I did was to do that. I mean, probably I'm still sleeping. Now I know I did. I mean, I had the triangle minus the sector, and I got this one.
Okay, but finally you
Yeah.
were able to get 2 centimeters square, right?
Yeah, that's the one. Yeah, because
That
at first
was-
I did. I mean, the whole sector, the bigger sector. Then I found that no, I'm getting this one, the last part, ACB. Then I said, oh, I need this. Yeah, no, I did.
Right.
Yeah.
Okay, that's fine. Okay, perfect. Very good. Okay, so this was basically the 7th question. Then this was also as homework, right?
Yes,
Yeah.
Miss. Miss, can you do it? It's part B.
Yes, okay. So both of you were able to show this?
Miss, I was able to do this one. Easy.
Okay, Munja, what about you? I could not hear you.
Yeah, I did.
Okay, perfect.
I was able to do that.
Okay, perfect. Let's talk about the second part then. So the second part of the question says find the exact parameter of the shaded region. So it says exact, okay? Now this is also an important keyword. We'll talk about it later on, but it's only for 2 marks. So let's see. Let me scroll up and see. Okay, so in the diagram, OAB is a sector of a circle with center O and radius 2r, and angle AOB is 1/6 pi radians. The point C is the midpoint of OA. Show that the exact length of BC is this. Okay, that is given. Now you need to find out the exact parameter. So for that, you have this. That is R root 5 minus 2 root 3. You already have AC, like that's given, and everything is in terms of R, so that's fine. And you are only supposed to find out AB. So for AB, we need to basically find out the arc length, and arc length is basically equal to R theta. So R multiplied by theta, that is pi by 6 radians, and this would give you pi R by 6. Okay.
Okay, Miss.
Now,
Miss, I got it how to do this one.
okay. That's fine. And then you're just supposed to add the entire thing. Okay, very good. You were talking about the third part then?
No, Miss, I just got it
Okay.
right now.
All right, okay. And it says exact. So exact makes sense here because obviously we have our So when we have R, we cannot do anything, like we would be writing it down directly. But if let's say this was some other question where R was known, exact would have meant that you're not supposed to change fractions to decimals or change surds to decimals. Exact means just write the exact thing you're getting. Do not write your answer in decimals. Okay, just think about exact as if it means that do not give your answer as a decimal. Okay, this is what exact is. Okay, all right. And for the C part, it says find the exact area of the shaded region. So were you guys able to do this part?
Yes, miss.
Okay, 1 second. Let me just quickly write down the answer just so you can check if you were getting the right thing or not. The shaded area should be r squared into pi by 3 minus 1 by 2. Munja and Rafi, please check if you guys were getting this as your answer.
Yes, miss, I got the same answer.
Okay, and Munja, what about you?
Ma'am, yes, I did.
Okay, so you got this. Okay,
Yes, ma'am.
this means that we are good with this and we are done now. So this means that the fourth chapter, that was circular measure, is done. And now we can talk about the next chapter. Anything that is coming to your mind? Any questions?
आवाज नहीं आती
Sorry, please keep Adil, please keep yourself muted. Yes, say it now, Mundia. Any other question? Anything that you guys need to ask?
No, miss.
No.
Okay. All right. So this means that we are good with the fourth chapter, and now I will just shift to my writing tablet and we will talk about the next chapter. Okay. Let me just quickly take out my notes. I'll stop the recording.